Okay, so now it's important to discuss how overfitting and underfitting occurs in a decision tree because this is something we will address when we build random forests. So when you have a decision tree, and let's say the decision tree is very deep, it keeps going, it goes to some 100 level depth, and you have some y equals 1 or 2 over there. So what happens when the depth increases? As the depth increases, right, the possibility of having very few points at leaf node increases. The possibility of having very few points at the leaf node increases, right? So this leads to overfitting because if you have a very deep tree and if you have a lot of nodes at the depth, this will basically lead to overfitting. If it's too deep, it'll lead to overfitting, right? Now, what if the tree is too shallow? Let's say I don't have anything. I just have one leaf node and I just have the response variables over here, y equals 1, y equals 2, y equals 3. This is a very shallow tree, right? You just have one node, and at depth 1, you have all the values of your response variables. So when your tree is too shallow, it's underfitting because, look, it's a very generalized tree, right? Using a very simple model to fit your data set. And uh, a small change in the model might not make any big change in the output variable. So that is basically a very shallow tree, and this leads to underfitting. Okay. So the thing is with overfitting, the interpretability of the decision tree also reduces. Now, decision tree in general are highly interpretable models, but if you have a very deep tree, it'll get very hard to interpret the model, right? You'll keep going if this, then this, then this, then that. You'll keep going for 100. Let's say if the depth of your tree is 100, you'll keep going for 100 times, and then you'll be like, then y equals 2, right? So it's very hard to interpret a very deep and a tree that overfits. So interpretability also reduces as your tree, the depth of the tree increases, and as it starts to overfit on your data set.